Очень много людей. Я первый раз
Yes, so many people.
выступаю, поэтому...
First time I'm speaking to such a large audience. I hope it will be okay.
доклад — это другой взгляд атакующего.
My presentation today is another attacker's view of ACL in Active Directory.
Не нажимается. Меня зовут Шлюндин Павел.
I'm Pavel Shlundin.
Способ связи со мной через Telegram. Ник Ряков.
Telegram is the easiest way to connect with me. I work for BSS. I'm the chief expert in defense. I'm sorry, in pen testing. And I'm also running a Telegram channel called Red Team Brothers.
Инструмент, который будет полезен.
And I'm trying to develop tools that would be useful to lots of people and make it available on GitHub. I hold some certificates. I'm also a member of a CTF team called Truvas.
Будет построен следующим образом. Вначале я расскажу теоретическую часть про ACL. Что такое ACL?
So first, I'm going to give you the theory on ACLs. I understand that we have both blue teams and red teams here. So I believe it should be of interest to everybody. Next, I'm going to tell you about the privileges that exist, about, DACL, SECL, and OCE, about privilege abuse. And there will also be a practical part of my speech where I am going to show something interesting. Do not expect any super rocket science or 0 days.
По отдельности они есть в открытом доступе. Я все это собрал. Единственное, что такое ноу-хау, это будет инструмент, который я покажу.
All the stuff I'm going to talk about has been previously publicly available from me, but the only know-how is the tool I'm going to show.
Вот, теперь работает. Да. Итак, у нас с вами есть Active Directory. В Active Directory есть очень много...
So we have Active Directory. There are numerous entities inside Active Directory. And they all have security descriptors. So all of them are protected assets, such as files in network drives. And finally, assets in Active Directory, such as, say, computers and the root objects and so on. So when people talk about ACL in Active Directory, what's assumed is that there is DACL and SACL. So SACL is security entity, while DACL is discretionary access control list, something that we are actually interested in. What is a security descriptor?
Здесь указка, но ничего не видно. Хорошо. Security descriptor содержит внутри себя...
My pointer doesn't work. So security descriptor contains the owner and the owner group, the people who actually created. And there is also SACL, which is empty, as the slide suggests. It's the usual case. And we also see DACL. DACL has a structure of its own, and it also has some data, which is effectively the ACE, access control entries. And these are the key terms we will need for this presentation. Security descriptor as such will consist of the following elements: the owner and the DACL. Like I said, DACL is a structure which contains a list of ACs and initially initial flags. There is also a security descriptor, which is contained in anti-security descriptor for every object. As the slide suggests, the Petrov has it as well. So he's got his own security descriptor. And this is binary data, which is then parsed to provide us with the structure shown below. In order to check it in GUI, we can see it in Hadoop. We press View, then we select Properties, we go to Security, and then we press Advanced. This is what we shall see. I guess most of you, Red Team and Blue Team, have seen it before. This picture is very good at demonstrating, the graphic part of what we have been discussing. So there is a protected asset. In this particular example, this is user P. Petrov, and he's got his security descriptor. At the top, we show the object, which contains security descriptor. So we see the owner. There is SACL, DACL, and the strings here. They actually form the access list. Access list is comprised of ACEs, and ACE can be set to either allow or deny, I guess, and it also has a list of rules for it. Access rules. So we keep going deeper.
Мы доходим до ACE, и это последняя сущность, которую мы будем разбирать.
So ACE is actually the last entity we wanted to discuss here. ACE has got its own structure as well. So a single line here will have its own structure. It has a 32-bit set of flags. But even more importantly, it has a 32-bit access mask.
Там, собственно говоря, видно, где они находятся. Access mask. Вот это самое, пожалуй, главное, на чем стоит остановиться.
Is critically important.
Из чего стоит access mask? Access mask это 32-битный.
The structure of access mask is obviously that of a 32-bit value, some number, and every bit is reserved for some function. So we see, for example, the first 4 bits, GV, GE, GR, and something else, they are the generic ones. And all security descriptors have got them. And they can be managed from the very beginning. Now, Linux got RVX, and the system is more complicated. So generic ones are read, write, execute, and there is obviously the generic all. So if, for example, one user has got generic all for another user or another object, well, obviously he can do anything. In packets, you can find a library that can support all things on AD.
Разными интерфейсами, в том числе с ACE-шками, с LDAP и так далее.
So, it can support ACEs and LDAP. And InPacket does a beautiful parsing of ACE. So ACE is shown here. You will see here who actually has rights to this object. This is Delta SID. And there is also a mask which shows privileges. This is ACE type 1. And we will discuss ACE type 2 eventually.
Дальше у нас есть какая-то зарезервированная секция 3 бита.
So we've got these generics, then there is a reserved 3-bit section, and then we have object-specific rights. What are these?
Как они выглядят? Собственно говоря, есть таблица сводная, где все эти...
There is an aggregation table which lists all these ACLs, such as create child and write property, and extended write, generic all, and generic execute, write, and read. So all of them are there in this table.
С предыдущего слайда. Мы видим то, что здесь находится...
Left and bottom screenshots comes from the previous slide. So we see the mask here 131380, and it's obviously in hexadecimal. I'm sorry, it's in decimal, and we turn it into hexadecimal.
Дальше мы по этой таблице можем разложить эту маску.
Then we can parse this mask using the table to check the privileges that this object has for user P. Petrov. So 2 in front means read control. Then 100 in hex is extended write. 30 is a write property and a read property. Well, because 30 is 0x10 and 0x20, and least child.
Таким образом, то есть когда мы в Адуке что-то нащелкали,
So once we've, selected some generics in a Duke and other properties, it's all represented like this in a compressed way. So there is a mask, there is a SID, and it's very easy to set these masks up. And we can check if such a mask is available for a given ACE. So we can, for example, configure a mask, or we can delete it using the XOR logical operation.
Собственно говоря, давайте с вами посмотрим, как ACE выглядит в графическом представлении.
It would be great to see ACE in GUI, and this is something we discussed previously. So we can drill into any ACE here to see what's inside. For every object in Active Directory, we will see a different set of privileges and rights, permissions, and properties. At the top on the left, we see it's for user P. Petrov. And the bottom, for the group, on the right, for the computer. The number of permissions and privileges is obviously different. It's easy to spot right away. We'll always be able to see that every object has got this generics like write permissions and read permissions. And there are also some object-specific privileges. This is where you may have the following question. Okay, it's 32-bit mask. It's object-specific, right? It's only 15-bit long. Obviously, there are many more tick boxes there in the computer field. What about the other privileges? Well, for the other privileges, we have a different type of ACEs, and they internally contain objects. So every object type has got its own GUID. And let's analyze it on the using the example of GUID. And they effectively enable us to give the user DC sync privileges. You probably know that it enables domain synchronization, I think. So this is what attackers use very often. So when users, for example, synchronize with Azure AD, can be targeted with Azure AD.
То есть, собственно говоря, получив привилегии учетной записи, которые
So, once they get the privileges enabling DC sync, we can actually compromise the whole domain. So we can see here that the first two object types, are in fact different. They're one byte different. Now consult the structure. Shown at the top is the old structure, which has masks in it. Shown below is the extended structure, which features object types. And it was added in order to support and maintain additional objects. And in order to make it expandable in the future, rather than, increase the bit size, they decided to use this object type-based model. So there is the object type field here, and you can also see SID here.
Создадим ACE-шку, где в object type.
Now, if we create an ACE, where we write one of these privileges in ACE, we shall see in a Duke a tick in front of it. This is how we can now craft pretty much any ACE. So if we want to, we can consult the table, choose a particular privilege, and do, addition, and write it there. If we need some extended privilege, we may want to consult the document, see the object types, craft it, create this ACE, and thus have ourselves a new privilege. So this is like deep-level exploration of security descriptors, SACL, DACL, and ACE. Now we have everything we need to make the next step. This slide, I've been struggling whether to include it or not. It shows something interesting. I knew that blue teams would be listening, not just the red teams. And it's an interesting element, really. It should be covered. In fact, for Windows and Active Directory, there are lots of weird things, really. Weird things that administrators and security people should know about. On the left, I wanted to create a new ACE. So I pressed Create ACE. I chose a principal, or a SID. This is effectively the administrator of the domain. For a user called user. Then I did nothing. So I created an AC from scratch, and it already was pre-populated with these flags. And therefore, it's so easy to miss this flag here, called Write All Properties. So if you created an empty AC, and you saved it, open it to see that, it's no longer empty. So you may think that if you create an empty ACE for some principle, you are okay. Oh, you aren't. It already has privileges such as write all properties. It's an interesting feature to know about. We shall also see during the demo. And I will be using Bloodhound with arrows and stuff. And you will see write all properties everywhere. This is not because I decided to make this demo easier. This is what you will see in real life. Privileges like this will be set by default. The best thing you can do is actually scroll it down and select, remove all the ticks or deselect all. So permissions are here, computer level permissions. So the stuff, you can show in the mask is there, but the one that can be fit in the mask is shown here. It's followed by properties.
То есть у объектов есть не только привилегии.
So the objects here have privileges, and they also have properties, and this is important. In fact, there can be so many properties. For example, if we have a privilege called write all properties, which means that, well, naturally we can write all properties, then under the hood, it will actually be different. For example, user account control property. This property contains a number, and this number can translate into a particular mask. And not any sequence of bits will work there. Again, it will depend on your privileges, and you can write there, that's right. So if it is writable, actually, I put it differently. All the listed properties are writable. So both as attackers and as SOC employees, we are particularly interested in MSDS key credential link. Popular thing now. There was a report published about a year ago on that. So you must have heard about shadow credentials. And there is a tool called Vishker, I think, on C# and Python, which enables you to write some key pairs, key value pairs, to that writable area, and then do authorization using it. MSDS allowed to act on behalf of whatever. Again, most attackers know it. So this is resource-based constraint delegation. So this is how you can actually abuse the privileges. Next one is machine account quota, which is another property. And by the way, set of properties available for different objects will differ. So naturally, this machine quota will only be found in the domain object, not anywhere else. and it will actually tell how many users you can add to it. Script bus and the next property are two interesting abuse trajectories. If this property is writable, you can actually write a script there, which will be launched when the user logs on. So Ivanov, for example, if he can write into Petrov's property, he can actually write a script into Petrov's writable property there. It's an interesting way of abusing it. However, it's an interesting attack vector if the user is actually live, if the user logs onto systems. While the second one is only relevant to terminals and terminal servers.
Хорошо, мы рассмотрели с вами property, и давайте теперь посмотрим.
We've talked about properties. Let's discuss shadow credentials. MSDS key credential link.
Мы с вами сейчас
A
поговорим.
great thing, isn't it?
И, собственно говоря, будем этим пользоваться активно.
Actually, we are going to use it a lot in the upcoming demo. So, for shadow credentials, some conditions need to be met. The domain functional level must be above Windows Server 2016. At least one domain controller should be running Windows Server 2016 or above. There should also be a certification center or PKI. Or ACLs. Finally, the attacker needs to have control to the account table in order to write properties of users or computers. If all these conditions are met, well, you guys work for companies that certainly know how to do that. You will certainly know that your domains are great, you've got good policies, and like 99% of companies present here today will have certification center and PKI properly configured. You must have read about certification center vulns as well, and they can be abused. But let's not go into it. Let's assume that certification center is properly configured. So, right, we can. What are we going to write there? There will be some key pair that we'll be using later on for authorization.
Мы сможем авторизоваться и идентифицировать себя как этот пользователь.
And once we get authorized, naturally we will be able to work on behalf of a particular user. So we have a client, we have a domain controller. Naturally, it will only work if it's Kerberos.
Собственно говоря, как это работает. Все мы знаем, что у Kerberos есть 3 головы.
Now, everybody knows that Kerberos has got 3 heads, so there will be 6 arrows. And we'll only consider, the first 3, I think, the ones you see in the slide. And they're different from your usual Kerberos. ASREP will happen in a particular format.
Именно мы будем проходить авторизацию именно по ключевым каким-то парам.
And we will be going through authorization using key pairs. And ASREP will be getting the usual TGT ticket. Next, we are requesting TGS. And why? And for whom are we doing this?
Как бы это работало в реальной жизни? В реальной жизни это происходит так.
You know what it would be like in real life. There is a corporate domain, and there are people with smart cards. The people who have a token or something that they will use for authorization. So they press their smart card, and all the services that go through NTLM authorization will not be available because this is Kerberos, right? However, we know that Microsoft loves to sacrifice security for convenience. And therefore, they've developed something we are going to abuse. At some point in time, Microsoft passes to the client's NTLM hash. So if one user can write the key credential link of another user and can put some key pair there, then he should be able to obtain the NTLM hash of that user. And I'm showing how it can be done here. Let's not go deep in it.
Глубже понимает это, да, то есть почему у нас именно передается в запросе ТГТ-билет. Ответ потому что
could be actually a good interview question, right?
у нас будет шифроваться не на
So TGS wrap
через механизм user-to-user, то есть это не простой TGS-билет, а
is exchanged in a user-to-user mode, so it's not your regular TGT ticket, and it's not encrypted using users' Kerberos keys, which would be the case elsewhere.
На сессионном ключе. Для этого передается
But it will use the session key for encryption. That's why you send TGT. And back, TGS wrap user-to-user is going to return a TGS ticket that can be encrypted, decrypted, and will take NTLM hash out of it. Shown below is the Wishcarrier tool that was developed on C#. And it enables you to list, create, and delete some key pairs. For example, here we can see that we've got two devices. And in fact, this tool is mostly used for tokens and cards. That's why I'm saying we've got two devices that we can manage. PT Swarm, I hope you're all subscribed to this Telegram channel. So PT Swarm recently released an abuse scenario. They say if you have a generic right privilege, and you have, as a group, generic right to computer as a user generic right, then you can get the NTLM hash for the computer. Well, I'm trying to give you the compact version of it, at least. This is not really a know-how. This attack was described in detail about a year ago. So we can see how it's done on Linux. And you can also do it on Windows using Wishcar and other tools. Let me add a bit more to this exploration so that another abuse scenario is more transparent.
Одно из самых популярных мест это там же в properties, я уже говорил, user account.
Also in the properties, there is something called user account control, and there is a value there, and this value transforms into a mask, and therefore, for a principal, there will be certain permissions. Now we are particularly interested in the top example here. So you will see that we've got several ones there, and the table below suggests that this is an option that enables us to switch on and off Kerberos during authentication, which supports the following attack, IS reposting. So if we can write into properties, then naturally we can write into user account control attribute, and then we can switch Kerberos authentication for users and get their TGT tickets. It's actually a bit more complicated than that, but in any case, we can get the TGT ticket, which we can then brute force offline. And then much will really depend on how crack or brute forcing resistant your passwords are. So we've talked about, masks and object types and properties and privileges. Now, all of this knowledge we'll try to bring together and see how a pen tester would work, and therefore how you may want to abuse it and monitor for it. So, for example, if we have domain administrator rights and we want to get ourselves the DC sync privilege and assign it to a user called test. I'm looking here at several tools, and they are slightly different in operation, so we'll check it out. Let's start with Bloody AD. So we've set all the flags, we gave the right count rights, and we set DC sync to user one, and we see that the attack is mountable. However, if we check the initial code, we shall see that the bloody AD tool, rather than setting, the 3 ACEs, it simply sets generic all. Well, generic all represents all the ticks there, so it will give us a DC sync privilege as well. So this is another option for sure. But deleting this object going forward will be pretty difficult. If a user had some privileges for the root objects of the domain, and we have created ACEs for generic all, it will be difficult to identify the legitimate ACE versus the illegitimate one. And if you're doing pen tests, you may want to restore the system back to normal. So the first option is that we can set privileges, 3 ticks for DC sync. We can do generic all, and that pretty much does it. Well, I decided to do it slightly differently. On LDAP shell, there is an option for doing that, and you can do DC sync for the user. So I'm crafting object types here, and you can check the source code to see how it can be done easily and conveniently. Now let's talk about abuse vectors. Now, people are often confused about that. So, for example, if a user has generic all privileges for a computer, in all probability, it doesn't mean that the same user should be able to access the same computer with RDP. Not necessarily. So, physical access rights and privileges do not really apply to everything. On AD, really, you will still need to sort of, hijack the object to which you have rights. The most popular type of abuse, if you have generic all rights, which is equivalent to having all the ticks and all the tick boxes, you can, for example, change the password for the account, and this will kick the machine out of the domain unless it's the domain controller. So that would be easy to notice, right? Alternatively, you can exploit RBCD, and you don't really need generic all here. All you will need is generic write, which is a subset of generic all. You can also read labs and GMSA, which should enable you to get access to local accounts, and you can also do shadow credentials. Shadow credentials attack, the one I described previously, which will give you the hash. And then you can also, for example, remove the smart card that you abused. So this is a computer abuse option. At the user level, you can do reset passwords. You can easily do that. Nothing will go wrong because of that. Next, you can do set SPA, which is also called target Kerberosing. So if you have generic write and you can write into this property, you can do ASPN, and then Kerberos will issue a Kerberos ticket for this ASPN. So this ASPN is owned by the user, and it will get this ticket encrypted with Kerberos key. Next is target reposting, right? So we will set a bit in a particular spot, and we will switch Kerberos off during authentication, and then we request the ticket, TGS ticket, and we get it. Shadow credentials, and finally script path and MSTS Intel program. Something I covered previously, this interactive logon and terminal scenarios. So generic all gives you max privileges. Now let's talk about these privileges and how they form an overall picture, so to speak. Generic all is the max privilege. Nothing beats it. It's the limit, so to speak. Now, generic all also includes such privileges as write DACL, write owner, generic write, and all extended writes. Write DACL enables you to write in permissions fields.
Представлены ACLs в графическом виде.
So here I was listing ACEs. So we can set, all top-tier ticks.
У нас есть привилегия write DACL на объект.
So if we have the write DACL privilege for a particular object, we can effectively do full control. We can actually escalate our privileges to generic all. Not that simple with write O. If we have write owner, we can naturally write the owners. Once we've done that, the owner of the object can always do write DACL. He will have this privilege. And we've just discussed how we can exploit write DACL. Now, generic write. Generic write can be, per user, per user group, per a computer. So all the kinds of objects that can be protected, but these are the usual ones we would want to exploit. So for a computer, we would do write RBCD. For the user, it can be target car browsing. For user group, it's pretty boring because what we can do at the group level is say add a user. It's not bad. So if we have generic write privilege at the group level, well, we can add new users to the group. And this group going forward will have some privileges, for example. And, we can actually add a GBE. All extended writes is often confusing to people. People often don't understand the difference between generic writes and all extended writes. They're actually different, by a single one, but this one gives you additional functions. So if you have all extended writes for a root object in a domain, you effectively have DC sync rights. If you have all extended rights for users, you can reset password.
Все, в принципе, на этот момент мы с вами поговорили, как абузить ACL-ки. Эта тема достаточно
So we have covered ACL abuse. This is pretty complicated, it's best to learn it in practice, but time is limited. So please consult this diagram. It has been around for a long time. I have not authored it. Now let me present my tool. So I developed it in BSS, and I was initially helped by my colleague in terms of writing this on Python. And after that, I'm sorry, I should mention that I found the initial idea in NPacket, so I didn't really do it from scratch. See, all the attackers will know MPLMX, and there is a -I key there, which I guess nobody uses. So when you are relaying somebody successfully to LDAP, it starts an interactive session. So that was, the initial LDAP shell tool. It was just a simple little module, which did provide some very useful capabilities, because if you have this LDAP shell in LDAP, naturally you can abuse ACLs. There were several options for abuse at first, and I decided to turn it into a separate tool, which I then expanded. I added, more abuse vectors, and it now covers all potential scenarios. And you know what? It is great for Linux systems because doing pen testing of a Windows machine is a very unusual case. It requires an unusual combination of either conditions or preferences. Function-wise, I'm not going to list everything that you can see in the screen. Let me just point out that getNTLM. getNTLM actually is a good abuse for the smart card scenario. So it will list will write the key pair that will request the TGET ticket, will get the session key, then user-to-user it will request the TGS ticket, and then we'll use the session key to unpack it, and we'll take the NTLM hash out of it. And after that, it will actually clean it up. It will delete this pair, which means like you get your NTLM hash and then you clean it up. You don't need to reset password. You do not need to fumble with the other attributes.
Хорошо. В том числе здесь есть функционал, который будет последний наш слайд. Это
the last slide I have here
DACL Modify. DACL Modify
covers DACL Modify.
Невозможно, поэтому, скорее всего, буду потом вносить либо в отдельный инструмент, либо писать более подробный help.
I think I will need to produce a more extensive help file on it, but in any case, we can actually craft any ACL. ACL for an object, ACL for a mask, and we can craft it for any principle. And it can be done very flexibly. So we can delete it, we can edit it, we can create new. And this will come in handy in the end when we are going to, say, clean up the results of the pen test. Now let's get practical. And actually, half of the time allocated for this presentation is over, so it makes a lot of sense. So assume we have a user who's part of the domain users group, and this group may have the add member privilege so that they can add a user to help desk 1 group, and this group will have generic write privilege for help desk 2, which means they can also add users to help desk 2 group. Help desk 2 in its turn has the write DACL privilege for user 1, but we also see the generic write error everywhere. Like I said, if we create an empty ACL, it will have generic write privilege from the very beginning. Like I previously said, this is what happens by default unless you are cautious. So the group has write DACL privilege, which means that we can set any permission we like. And user 1 has a generic write and write owner for user 2. You may remember I covered this previously. We can actually use it, and then the owner can use the DACL privilege. So it's a 3-step abuse. Then user 2 has generic write privilege for server 1, and server 1 is part of help desk 3 group, which has generic all privilege for user 3, and user 3 has a force change password for admin, and admin has a write DACL and generic write for the root object of the domain. Saying something like this in a pen test is difficult, but individually all these privileges you will come across. No problem there.
которые часто видны, часто встречаются.
So this is something we do see a lot in numerous projects. And please note that Bloodhound is no panacea. There are lots of privileges it will not show, but this is good topic for a different talk. Now, I will go through a demonstration soon, and I was afraid you wouldn't be able to see it in the screen, so I'm not going to show this picture going forward. But if you can commit it to memory, that should help you understand the demonstration. We have red teamers here, right? So, how long would it take you? To do it in Power Review, like 10 minutes? Yeah, that's what I thought. So I tried putting it in a single tool. So now it will take no more than a minute. Now let's discuss how we're going to do the attack. Let's plan the attack. Now we see the right owner, which means that, okay, we can modify data easily. But now let's talk about how we are going to mount the attack. And let's assume there is no certification center in this domain and shadow credentials cannot be used, which means that's we're going to stick to the old way of doing it. Makes me think of my lab. Often you don't have certification centers in labs or in smaller networks. So Help Desk 1 can add members, just like Help Desk 2. and there is no way to abuse it. User 1 can do target Kerberos thing and shadow credentials. As we have discussed, we're not going to use them. And we can also get escalation to generic all, and there is also right DACL there. How going to attack user 2? Same thing, really. At the end, say we can write owner. And just like before, we can do something to generic all. Then, in order to capture SRV1 server, and we have decided not to use shadow credentials, well, this means that we're going to use base constraint delegation. User 3, for which we can reset password and do everything that was listed before. At the admin level, naturally, we can do change password, reset password rather. And the last step is that we are going to create an ACE where the right user will have a DC sync privilege, and thus we're going to compromise the domain. This is the plan. And I've shown in the RAT what we're going to do. We're going to to add 2 users. Let's assume that user 1 actually has a weak password. So we can do roasting there. We can brute force their password. Then we can do set owner. We'll escalate to right DACL, and then we'll escalate it generic all, and then we'll reset password. Because with generic all privileges, we can do that. Well, naturally, with right DACL, we can do even more than that. But let's stay at that. Or we can establish an AC that will enable us to do exactly that. But this is a sub option. Then we do RBCD. Then we reset password, we'll reset password again, and then we'll set a DC sync for the privilege. So please launch my demo now. So we are starting LDAP shell with the user who's a part of this domain. So the software is running. And the user can add users to help desk 1. We are doing it for ourselves. And help desk 1 can add users to help desk 2.
У нас была привилегия, которая позволяла нам писать в DACL, писать в property, и, соответственно, мы...
And we also had a privilege that enabled us to write in properties, and we are switching off Kerberos pre-authentication.
Ой, прошу прощения, оговорился, ACE reposting. То есть мы с помощью скрипта get np users получаем TGT-билет и дальше ставим его хэшкатом.
So now we are getting the TGT ticket with a script, and we're using Rocky as the dictionary. We are doing the brute force.
Есть пароль слабый. Ну, здесь пароль слабый. Надеемся, что он QWERTY 1, 2, 3. Нам подсказывает то, что сбрутился один пароль.
This will work if the password is simple, like QWERTY 1, 2, 3.
User 1, пользователь user 1. Мы сбрутили пароль, и он действительно QWERTY 1, 2, 3. Мы угадали пароль. Дальше мы...
See, we've been lucky with the password.
Потому что она нам еще пригодится на шаге с эксплуатацией Resource-Based Constraint Delegation, RBCD. Добавим с помощью...
And now we're also adding a machine to the domain that we're going to need later in the RBCD stage.
Мы переключаемся,
Next.
Обратно, включаем Kerberos pre-аутентификацию пользователю, сразу возвращаем.
We switch the Kerberos pre-authentication back on to keep everything clean, and we do switch user to user 1.
Set owner для user 1, а для user 2 user 1. Устанавливаем generic call для user 2 user 1.
And we set user 1 as the owner for user 2, and then we do generic all for user 1. Then we change password for user 2 to password, and we switch to user 2.
Переключились в пользователя user 2. Дальше мы устанавливаем set RBCD делегацию от нашего компьютера, который мы сейчас только что создали. Компьютер у нас назывался RBCD. Устанавливаем.
Then we do set RBCD delegation to server 1, and then we exploit RBCD through set ST scripts, and we request Kerberos ticket. We impersonate the domain administrator, and we use this ticket in order to compromise this physical server.
С помощью LSASI утилиты мы вытаскиваем NTLM хэш машинной учетной записи. Все, мы захватили.
And then together with, with the LSASI utility, we get the NTLM hash. This is how we now own the machine, the system. Then we can get ourselves the privileges for it.
которая, да, в том числе аутентификация по PassThe у меня.
So you may remember it was part of the group. And the NTLM hash-based authentication is working now. And the group that had the privileges, change password privileges, we're doing it. So we've reset the password for user 3, and we switched over from user 3. No, I'm sorry, we've reset the password for the admin, and we've switched to the admin. There was a whole chain of actions, and now we see DCC for the first user, user 1. Which means that we have completed the chain and we're now doing the DC sync attack. This is how we have captured the domain, and we've got ourselves the account for the domain administrator. This is how it works.
Все, можно вернуть презентацию. Это достаточно такой, ну, нужно уметь, да, то есть все это эксплуатировать, получать вот эти привилегии. Сейчас мы с вами посмотрим, как бы это выглядело.
One needs to know how to do that, how to escalate privileges like this. But now let's discuss
Настроено либо PKI, либо центр сертификации.
What would you do if the domain is running PKI, a certification center, which 95% of them do? Which means that you can also do shadow credentials.
Ну, 2 раза добавить пользователя, тут без вариантов. И дальше shadow.
Well, naturally, we'll want to add the user twice, then we do shadow credentials. So we do shadow credentials pretty much everywhere, and then we do DC sync attack in the very end. This is the plan for this particular demo. My spoiler is that it will be boring.
Опять-таки запускаем LDAP shell с нашей учетной записью user, которая.
So we fire up LDAP shell with our user 1, I think, credentials.
И дальше добавляем user в helpdesk 1. Дальше helpdesk 1 может добавлять пользователя в helpdesk 2. Добавляем.
So we're adding a user to helpdesk 1, and helpdesk 1 can add users to helpdesk 2. Now we are in helpdesk 2, and then, as you probably remember, we had rights to user 1.
Мы будем, договорились с вами, эксплуатировать через shadow credential. Поэтому говорим get NTLM user 1. У нас добавляется новый девайс.
Since we're using shadow credentials here, we are requesting TGT here. We're getting TQS, we're extracting NTLM hash, and then we're cleaning this user device. This is where we get NTLM hash for user 1, and we switch to user 1.
И получаем хэш user 2.
We do all this, and we get the hash for user 2. I told you it would be boring.
Дальше получаем NTLM хэш SRV1. машинной учетной записи.
And next we get NTLM hash for user 1, I think, and we switch to it. Then we get the NTLM hash for user 3, and we switch to user 3. So this is how we're actually capturing account after account.
Получаем NTLM hash админа. Он имеет права.
Next, we grab the NTLM hash for admin, and he has the right DACL rights. And after that, we can give DC sync rights to user. And then we can do the DC sync attack, which means that we did pretty much everything we did at the previous stage, but it's easier and less boring, more boring now, but faster. That's it. Now we own the domain.
Так. Ну и как бонус, в принципе, как я вам рассказывал, у меня есть функционал DACL Modify, и кроме тех частей, где мы сбрасывали пароль,
like I said, I have the DACL Modify function, and now pretty much most of these ACLs we can bring back to pre-attack stage. Like now we can connect using LDAP shell and
Да, здесь вот ошибочка небольшая на слайде. Мы удаляем у пользователя.
I'm sorry for the typo. Naturally, since the user has DC sync rights, this is where we're going to delete them. And after that, we are going to clean up our BCD for server 1, and then using modify, we'll remove generic call for user 1 and user 2. And after that, we will delete DACL for user 1 and user 2. And after that, we will remove generic all from help desk 2 for user 1. And after that, we will delete user called user from help desk 2 and help desk 1, which means that we've cleaned it up. And, after that, we can send a report to the client so that they know which privileges to remove. I've given you the theory, I've shown you the demo, and we've talked about various privilege abuse vectors. And I've shown how I've combined several useful functions in get and TLM script. Do you have questions? Thank you very much. Can you wave? I have a bunch of simple, short questions. At first, you said that all ACLs are stored in the security descriptor attribute. Well, can't you just, use Python libraries or shell LDAP to load them? Oh, it's not difficult, really. You can do it. Parsing it may be difficult, though. And this function is not repeated in other tools because there is, Bloodhound already. I mean, I could have expanded LDAP shell, but why should I do that? Because there are so many tools that do it so much better. More. For example, if I have downloaded the security descriptor, can I, parse it so that I can avoid all these operations, so that I can get to see, write DACL and generic all and everything, so that I can do my audit without the Bloodhound? It's a great question. I'm sorry, I'm not prepared for it, though. I guess that PowerU can do that. Or alternatively, we can use PowerShell. Or alternatively, you can use in-packet on Python. No, in-packet doesn't do it elegantly. The source code will have some constants. All right, and you will not have things like generic all from the masks. Now I've found MS-LDAP utility on Python, but it's not canonical. So you will still need to perform some bit-level operations. Yes, I'm sorry about that. And PowerView will not really parse all the ACLs for you. So in one property, for example, you'll not be able to see it, which means that without PowerView and Bloodhound, we cannot do much. Well, even they will not really show you generic all and generic write. I've also been thinking about talking about things you won't be able to see on Bloodhound. That would be also an interesting topic. Is it actually safe to, download them from all objects, even if I have like 100,000 assets? So it will be okay for the controller. Yes, that's right. Where does it make sense for us to check them, for users, for user groups, for computers? Is that it? Well, there are some exotic ways of abusing ACLs. It's pretty interesting to see privileges for accounts. If you have the privilege to add users, and you also have a setting that lapse is automatically applied to everybody who joins it, then effectively you can bring any computer there and get lapse from it. What about GP-Link? Yeah, GP-Link is obviously an option once you have the GPU. What about attribute rights? How are they implemented? Through object GUIs? That's right. So if you have write all properties, you can effectively, well, indeed, write all properties. And if you have the same ACE with write all properties, well, you will be able to write only specific properties. Can we, where to learn more about these GUIs? I've been, going through Microsoft Docs for that. Now, when I studied it,
То есть именно вот
You
такие
know, I would
инженеринг, да, то есть ставилось.
do sort of reverse engineering.
Ладно, все, спасибо, у меня все.
Мгм.
Okay, thank you, I'm done.
Так, вопросы вот здесь.
Questions? Over there?
Добрый день.
Привет.
Да, привет.
Hi.
Спасибо за доклад. Вопрос с точки зрения мониторинга, понимаю, это немножко не твое.
Monitoring question. I understand it's probably not really a cup of tea, but
Шумные вот такие штуки.
have you considered, how noisy these things may be,
Первый вопрос. И второй вопрос,
for monitoring purposes?
проставляет ли он
And,
основные права?
Will generic all effectively give other rights to? Yes, it effectively ticks all the boxes.
Вы будете видеть то, что они во
So
всех полях.
that's what you're going to see in Hadoop.
Мониторинга, ну, вообще это легитимные штуки, да, то есть, например, добавить пользователя в группу, она редкая штука.
And this stuff is legit. I mean,
Вот,
adding user to a group,
можно ловить
not something you do every day, but it's legit.
Credential, да, ее можно ловить. То есть,
Say the shadow credentials attack, it has a specific pattern, so you should be able to monitor for it, and it makes sense. Yes, and changes in in other respects, they do happen a lot, like you add new users, and if a user is added to a group, well, some ACEs will certainly pop up. If you deploy Exchange, there will be so many changes in ACE, you will see a giant false positive. It will look like a serious attack. I'm not a SOC guy, but that's what I'm thinking. Oh, I'm told that my time is up. If you need me, you can find me on Telegram. I actually have 2 T-shirts for those who've been listening. Thank you.
У меня есть 2 футболки и 2